IntelliJ tells me I have to make it as an integer parse int, but even when I do that, I get that number format exception
Okay.
error.
Let me have a look
Yeah.
at your code. So load cargo, string description. Why
So
are
that's exactly what you said I
you
have to do.
parsing an int? So in your constructor, you're expected to create the cargo array using the maximum capacity. Are you following what I'm saying? Let me share my screen
Sorry,
with you.
sir?
Let me share my screen.
Oh, let me just quickly go on YouTube.
Oh no, it's fine. I'll share it on the Google Meet quick. So we'll go to the assignments. Assignment 2. So let me just make this a bit bigger. We're talking about task 2, the delivery vehicle. A private attribute. So task instruction 1, bullet 1, a private attribute cargo list of type string array. Right?
I did that.
Yeah. So during the constructor, we use the max capacity parameter, which is an int, to create a new array for the cargo list. So
I said cargo list equals new. Yeah.
Yeah, go ahead.
Wait, let's say I can show you this. I can show you what I do. So yeah, this is basically what you. I hope I'm doing this right, but this is what I did for number 1.
Yeah.
Sending it now. Here you go. Okay.
Okay.
So
yes, so that's correct, right?
I'm not sure. Yes.
So you have created the array for the cargo list. So it exists in your class, which means when you go to the load cargo method, you don't need to create a new string array.
Yes. Okay.
Instead, you need to keep track of how full the cargo list array is.
Yeah.
So the cargo list is a partially filled array, which means every time you call load cargo, you need to check whether or not the list is full. And if it's not full, you want to add the description to the array. You're inserting the description into the array. Does that make sense?
So must I? Is this like an array list or not an array?
It's a normal array. It's a primitive array, not an array list. So maybe I need to let me draw something here. Hold on a second. Grab my pen. So I'll get myself this. If you have a cargo list, right? This is an attribute. It belongs to the object, which is the delivery vehicle object. Which means in any method inside the delivery vehicle, we can access the cargo list. In the constructor, we said new string array, right, with some number, some capacity. So we now know we can store, say, 5 items only in the list. And what it's done when we created in the constructor, what it's done is it's created an array like this with 5 different spots for strings.
Yeah.
So on, right? So when we call load cargo, when we call load cargo, we give it a string, which is the description. So we want to then load the cargo into our cargo list.
Yeah, that's about
Say again?
I put it in the.
Well,
that's about the like how to put it.
yeah. So how do you access an element in the cargo list? You give it an index, right?
When I say yeah.
And then you say is equal to whatever your string is.
So don't I say cargo list equals to the load cargo then?
So yes, but there's a couple of cases. So I don't know how to say this without giving too much away. In essence, if you call load cargo once, how many items should you expect in your cargo list?
Isn't that number 5?
No, so that's the maximum capacity that you would have.
Okay.
But then, so you can think of it like you have a shelf where you can store 5 different things, right? But when you build the shelf, you need to say, I need to be able to store 5 things in that shelf. Are you with me?
Yeah.
Okay. So then you have a method that will load something onto the shelf, right?
So mustn't I? Okay.
Yeah, go ahead.
I was thinking that so for under my public void load cargo string description, do I bring the cargo list in and put that square brackets and put the description in there? I don't know if that makes sense of what I did.
For an array, such as the cargo list, we need to index the list. This is a number, right?
Yes.
And then what is the type when we access this element at this index?
Isn't that the what is the type? Is it a int?
It'll be a string. So if you have an array of integers.
Oh, it says I made it a string, so it's an array of strings.
Yes, it's an array of strings.
Yes.
And then this number here is the spot in the array. Right?
Yeah.
So then if you say equals some string, then that will go to this spot and put in our string.
Okay.
Does that make sense?
I'm trying to see.
Maybe a demo is then in order.
Like I see what you're doing, but like now, whenever I put the description in the thing, it keeps on saying that it's an integer. Why is the description being an integer?
Because
even by
your syntax is wrong.
My syntax.
Yes. So you are saying the following: your array, right? You have your array, and you're using the square brackets.
Yeah.
Right? You're trying to put a string in here.
Yeah.
You can't do that. This is the index for the element.
Oh, so I must put like a 0 in there.
A 0 or whichever spot it needs to be in the array.
Yeah.
So if let's forget about Java for a second. If you had a Python, did you do lists?
Yeah.
Okay. So in Python, you have a list of strings. Right? And there's just 2 items. There's A and there's B. How do I access A in this list?
You say, don't you just say list 0?
Yeah. Right? List 0. So I use the position to access the string.
Yeah.
So if I want to access B,
It's number 1.
yeah, list 1. Okay.
Yeah.
So now with Java, I have an array of strings. Right? How do I access A?
It's still 0.
Exactly, and B?
1.
Okay. So when we say array, or the name of the array variable, square brackets, and a number, we are referring to the position, right?
Yeah.
And in that position, we are storing a string type, right? So if we wanted to assign a value to 0, like if we wanted to replace A, we would say array at this position, 0, meaning A, is equal to what?
The description.
The description, exactly. Or whatever string we have, right?
Yeah.
So you can imagine if you said beforehand that our array has 5 spots and they start off all empty, right? Whenever we load cargo, we load it into the earliest spot, and then we take note of how many items are in the array. We remember.
Yeah.
And so this is considered what we call a partially filled array. So the next time we load cargo, we know to skip over this spot, and we go to this spot instead. And the next time we load cargo, we go to this spot, so on until we reach the end where we have too much cargo. So if we try to load a cargo, but we already have 5 pieces loaded, we don't do anything. We don't add it to the array.
Yeah.
Does that make sense?
Okay. Yeah.
Do you understand what the error is? Yeah?
I think I'm starting to get it.
Okay. We'll start the lecture now, but if you're still struggling with it, we can talk about it afterwards.
I'm sorry, we can start the lectures now, sorry.
Okay. Yeah, well, we can talk about it again afterwards, okay?
Yes, sir.
All right. Welcome, everyone. I think the live stream is up. Let me just double check. Yeah, the live stream is up. Welcome. Someone asked, can you also explain task 1, number 6? You don't understand the distance formula. Okay, I will look at that towards the end. Are there any comments in here? When you print your cargo list, it only recognizes the last description as if it didn't store the first description. Okay, so we'll talk about that. All 3 of those questions. We'll do Akib's question, Gabriella's question, and Worldmaster. I don't know what your name is. We'll do those at the end, but today we need to talk about polymorphism a little bit. So we're going ahead with object-oriented programming, and then afterwards we'll try to answer some of the assignment questions. I have made it a bit shorter because I expected there might be assignment questions. So let's get through this and then we can keep going with the assignment questions. So yesterday we discussed more inheritance. Specifically, we discussed the idea of using super to refer to a parent object or a super class. We also discussed method overriding. Method overriding is where we replace a method that exists in a superclass with a new implementation. Not to be confused with method overloading, where we change the type and number of parameters. If you recall, a method can be both overridden, and overloaded. All right. So even though overloading is not equal, it's not the same as overriding, right? Even though overloading is not the same as overriding, a method can be both, right? When we override a method, right, we are saying in the parent class we have method A. So in the parent class we have method A. and then in the child class or the subclass, we re-implement, we override method A. Okay. Overloading is the idea where we have a method with a, say, argument 1, and then we have another method with, say, 2 arguments. I don't know, get O or P. Right, so we have 2 arguments. This is called overloading and not overriding. All right. So we also discussed how when we use the super keyword, we could only go up to the parent or the superclass directly above our current class. So Java only lets you extend, so undergraduate student extends student. You can only extend or derive from one class in Java. Other languages let you do multiple inheritance. Java does not. So because we have an undergraduate student extends a student, we have some sort of class student up here, and then we have a class undergraduate student over here. And the typical format is that we have an arrow showing that an undergraduate student is a type of student, or an undergraduate student extends a student. However, if you recall, a student class is a type of person class in this way, and then an undergraduate student is a type of student. However, when we say super, we can only go up one level max. Okay, and then from the student we can go up to the parents. Okay, one level each time. We can't jump like this up more than one level in the inheritance chain. So that's why super.super does not work. Okay. All right, so now we need to understand something about classes. What you should already know, and hopefully I've been making very clear, is that in Java, a class is part of the type system. It is a type. So in Java, we have the idea of primitive types. Primitive types such as an integer, a Boolean, a float, and so on, right? But we also had more complicated types, such as a string, or a scanner, or an array list, right? And these are also types, but they're more complicated because they're viewed as a class. And when you create a new class, that instance is an object. Okay. So in Java, classes are types. Okay, so this is the key thing we need to know when we do polymorphism. For example, with the undergraduate student extends student, we had that idea where we have an undergraduate student is a, and listen to the language here, is a type of student because it extends student, and a student is a type of a person. All right, so it's no coincidence that we say they are a type of, or they extend the classes. Now, what polymorphism means is that something like an undergraduate student, let me just draw the chain again. Something like an undergraduate student is actually just a student with a degree name, right? We have an extra attribute for an undergraduate student, but it has all the attributes of a student as well. And that a student is just a person with a student number. All right. So we talk about a person being the ancestor of an undergraduate student. They're commonly called is-a relationships. So is-a relationships is a more general programming or modeling language term for inheritance relationships, and has a relationships are related to composition. But don't worry about that. We're just talking about is a relationships at the moment. Now, what this all means is that with polymorphism, we're able to treat derived classes like an undergraduate student or a student as any class further up in the chain, in the ancestry. Okay, so if we have a university, the idea of a university, there are various people. There are students, undergraduate students, staff, visitors, parents, whatever. There's a lot of people at a university, but they are all a person. Okay, and so with polymorphism, we can treat anything that is derived from person, any class that is a subclass of person, we can treat as if they were a person. All right, so let's look at this example. Our university is a very new university. It is a class called university, and in the main method, we create an array called people of type person, and we contain 3 persons in the people array, right? For the first person, or the first person in the array, we say it's a new person whose name is teach. Very inventive name. For the second person, it is a new student called tutor with a student number 007. And then for the third person, it is a new undergraduate student called undergrad with a student number 008 and a degree name CS. Okay. Now, in the Java type system, we must be careful because we have a person array, right? Java won't let you put anything in here like an int or a float or whatever because it is expecting this person type. However, because both students and undergraduate students are a type of person, they're allowed inside the array. And this is how polymorphism works. A class can be treated as any of the superclasses up its inheritance line. Okay, so with all of these 3, we create them, and then we can iterate through the whole array and call .sayHello. And if you recall, person had a method called sayHello, right? Yesterday, we looked at overriding the sayHello function in the student, who now also has their own special version of sayHello, right? And then the undergraduate student also overrides the sayHello method, and the undergraduate student, when they say hello, they also say what degree they're studying. Okay, so if we run this program, we will get the following. Hi, I am teach. So this is the person. Hi, I am tutor with student number 007. This is the student. And then hi, I am undergrad with student number 008. My degree is CS. And this over here is an undergraduate student. So you can see how we are able to store different objects as if they were a person, right? So we're able to store different classes, different object types, as if they were the person, because they are all derived from the person class. However, when we call sayHello, we are calling the specific method that is attached to that is attached to the class that we have when we created the object. Okay. So I need to stop here and make sure, is everyone with me?
Yes, sir.
Okay.
So that thing just printed out the array.
Yeah, so it printed out the array and it just called .say hello on each object in the array. Each presumably person object in the array. But it would call the specific method related to the class that we use to create that object. Does that make sense?
So it's also bringing out the message of .say hello.
Yes. But specifically the one related to the one found in the class that we use to create that object.
Yes, sir.
Okay, so this is polymorphism. A type can be treated as a different type up the inheritance ancestry. Because when we do inheritance, we go from a more general class to a more specific class. Okay,
Yes, sir.
which means we can go back safely because it gets more and more general. So if we then had different classes, like different derived classes at different steps, these can all be treated by the ancestor, treated as the ancestor class. And that's what we're seeing here. We're seeing that the ancestor class is the person, then we have a student, and then we have an undergraduate student, and both the student and the undergraduate student are being stored in an array of type person. And when the time comes to call a method on them, we actually just call the method available in that class. Okay, so that's polymorphism. So the definition is that a subclass can be treated as any superclass type, any ancestor. Dynamic binding is the idea that a method will be called based on the class that is used to create the object and not the type of the variable. Okay, so this is the tricky part of polymorphism. This is the part that will catch you. So be very careful about this. Understand this well. So if we go back to our example, when we created a student and we called say hello, then the dynamic or late binding will say, okay, when you call this method, I see that you used a student to create this object, and so I will call the method found in student, not the method found in person. All right. So dynamic binding or late binding, very important. Make sure you understand it. It is a behavior of Java, and Java is polymorphism. Okay, so that it's an attribute of object-oriented programming languages, specifically Java. Other languages might have a different version. So, formal definition, if you get it in a quiz or a test, polymorphism is the ability of an object to be treated as many different types, specifically for an object to be treated as an ancestor class. Okay. Any questions so far? We have a couple of slides left, and then we can do the assignment questions. Okay. So now we get to the Java object class. And whether or not you explicitly said it, all classes is an ancestor of the Java object class. So this means you can create a print line method that takes an object parameter, meaning you can pass literally any object, an array list, a scanner, a string, your own custom person class or whatever, you can use the object type to mean literally any compatible Java object. Okay, because it is the ancestor. It is the class from which all other classes extend. Okay. So, in terms of polymorphism, implicitly, all classes have an ancestor called object. All right. So we can use object to specify very general methods that accept kind of any object and see what sort of abilities it has. However, it can also be useful for just making sure that you can accept literally any object. All right. However, when we do something like this, and the same with the person class or whatever, say you asked someone else to write a class for a postgraduate student, right? And you want to make sure they're able to call the say hello method, but they might not. Or actually, a better example, say that the school eventually has sentient robots, and now you have a robotics student that is not a person, but you want to include them as part of your university, or at least as part of things that can say hello, right? So when you want to make sure that a set of classes has the same methods or behaviors, we can use something called an interface. And we'll talk about this next week. So you can kind of ask, like, how do you make sure that objects all have the same methods? Well, one of the answers is if they're all derived from a specific class, you restrict it to only the methods available in that class. So for example, you might want to try take this code when I upload it, and instead of this line over here, you want to say people, right, blah, 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 dot get student number. So I want you to try this and see what it says. Okay. The other answer is that you would use something called an interface. But don't worry about that. We'll cover that next week. So, to wrap up here, classes may inherit from other classes. So you can have a class like a person and it inherits from another class, or even the Java object class. Subclasses extend the superclass, and extend is the Java keyword. We can say subclasses extend superclasses. They also inherit from whatever. Subclasses may override methods in the superclass, so you can replace a method with a new implementation. Subclasses may not access private variables or methods in the superclass. In fact, no one may access private variables outside of the class. We also had the idea of protected variables. And a protected variable is available in the current class, as well as any classes that derive or extend from that class. Okay, so if you had a superclass and then different subclasses, it means protected means that that attribute or that method is available in all of these derived classes. Then for polymorphism, subclasses may be treated like any of their ancestors. And if a subclass overrides a method, the newest version of that method will be called, and this concept is called dynamic or late binding to the methods. Okay. So that's it. For further reading or further pondering, go have a look and see what purpose the protected access modifier would serve with inheritance and polymorphism. We should add polymorphism here. Right. In the person.java, you can write an equals method that checks if the names are the same. Then you override this equals method for checking if two student objects are equal. And then in university.java, use a for each loop to print out all of the people and then see, like, is there a different result? What type would we use in the for each loop, right? Because a for each loop, if you recall, goes for type specifier, the name of the variable, and then the array we are looping over, right? So what type would this be? That's for you to think about. And then finally, there's kind of the access modifiers, which is a good idea. Go and have a read on the Java access modifiers. There's also the Oracle documentation's good. The textbook is also good. Finally, we have this idea of the kiss and dry principle. This is something I mentioned a few times. Dry being don't repeat yourself, kiss being keep it simple. So yeah, that's about it. I'm going to open it up. We're going to tackle those assignments, but make sure you understand polymorphism. If there are any questions, feel free to ask now. Remember, your assignment is due tomorrow at 11:55 in the morning, and your new assignment will be released at noon. And there'll be a question and answer consultation session Friday afternoon as well. So thank you very much. I will open it up to any questions about the lecture content, and then we'll tackle questions about the assignment. Any questions about polymorphism?
I'm trying to think.
Say again?
I'm saying I'm trying to think of a question.
Oh, okay. It's quite a bit. I highly recommend you review the work on this, especially so that you understand it correctly. This is why in the beginning of the term I wanted to make sure that if you weren't up to date with your Java, or if you weren't confident with your Java, you got confident really quickly, because we're building on a lot of concepts really quickly as well. Next week we'll do a lot more examples. We'll cover interfaces, and I think maybe a bit of generics, and then we'll do examples and examples of inheritance, polymorphism, and everything. We'll also cover a special topic of your guys' choosing, so if you have an idea, feel free to ask. All right. If there are no questions about the lecture content, I'll go ahead and try to answer some of the assignment questions.
Sir?
Yes, go ahead.
I take it tomorrow's assignment is going to be based on polymorphism and the superclass and inheritance.
Most likely, yeah.
Okay.
So I'll have a look. I might simplify it a little bit.
Please.
But, yeah. All right, so the first question we have, Akib, I'll get to yours a little bit closer towards the end.
No worries.
First question I have is, when I print my cargo list, it only recognizes the last description as if it didn't store the first description. Okay, so that's Gabriella. I'm assuming there's kind of two things that could be happening. If you have an array and you're storing things in it, especially if it's a partially filled array, a mistake some people make is that they always put things in the 0 or the first position. So you have a look at your code, and if you're saying something like cargo list, right? It's important that this number here dynamically updates with how many items are in your list. So if you never change this, if this is always, for example, if this is always 0, right? What's going to happen is you're going to repeatedly overwrite this position in the array. So every time you call load cargo, right, and you give it some description, if you don't dynamically change this, you're just going to keep overwriting the description in this position. And then when you print it out, you only have the last description you put in. So, Gabriella, is that the problem you're having? Does that sound like your problem?
I don't think so, because I'm using a for loop and I tell it to always change that number.
Okay, so when you use your for loop, let me actually do an example. So we'll pull up some code, demo.java, go here. So if I create an array list, string, like a string array of names. I say it's a new string array, and we want to take 5 names, right? So actually, let's make this an attribute like this. Right, so we declare it, and then at the very beginning we create a new one. Right, so whenever we add something to the array, we say names 0 is equal to something. Something like that. So now we expect this array to look like this. Right? I think that's right, yeah. Now we can say for and have a for each loop string name in names, and say system.out.println name. So if we ran this code, go here, and if we ran this code, oh, did I mess this up? Oh, I need to save this 1 second. Compile non-static variable. Ah, okay. Just for now, we'll ignore this. We'll just say so if we run this, we'll see that even though number 1 has a string, the rest are null, because those strings haven't been filled in. So when you print, do you get this?
I get another null somewhere. It's in a random spot.
It's in a random spot.
Yeah, like a slot above, which is weird.
Okay. So this is difficult without giving things away.
It's okay.
How would you mind sharing your code with me?
Sure.
Yeah, you can just share your code with me and I'll have a look. In the meantime, I'll try to answer another question. Can you explain task 1, number 6? You don't understand the distance formula and those a, b, x, y, z variables. Yes, so with a, b, x, y, z variables, and this relates to a question I had from a student as well about why their distance formula wasn't working. If we look at the instructions, which I'll pull up in just a second, if we look at the instructions for task 1, question 6. Question 6, task 1, instruction 6. It says write a public method called distance2 that takes a basic vehicle parameter. So when we say write a method called something, we would have method name like distance2, right? We have a method name and takes a basic vehicle parameter. So we have a parameter here called of type basic vehicle, and we call it something, right? So that is the method signature that's described to you. And if we need to call it outside the class, we call it a public, right? Then it's asking you to calculate the distance. So this is something I talked about last week, but distance2 returns the straight line distance between two, there should be vehicles, as a double. So we know it returns something of type double. So the return type here is double. So we have some double, like an answer, and then we return the answer. So now, what attributes does the basic vehicle have in terms of position? And so the straight line distance would be the absolute difference between the x position, for example, and the absolute distance between the y position. So this would be vehicle A, vehicle B, vehicle A, vehicle B, and another position, right? Or vehicle A and vehicle B. So this formula is what I'm describing in the line here. And there is a function math.square-root, which looks a lot like this, which looks a lot like this, square root. And there is a function math.pow, which looks a lot like this, which looks a lot like this over here. So if you had a vehicle, what attributes do you have? Oh, I can't say that. What attributes do you have is a question you should be asking yourself to calculate the distance. I can't really say more than that. So if that's your question, then that's what we're talking about. Gabriella, do you have your code for me that I can take a look at? You can email it to me or WhatsApp it to me.
Okay, I'll email it now.
Okay. And then Akib, what was your question? Sorry, let me pause for a second. Are there any other questions regarding the lecture or otherwise? If there are no questions, then I'll stop the stream and you're more than welcome to enjoy the rest of your afternoon. I'll be staying behind to help some students with the assignment questions they have. Okay, if there are no further questions, then, or no further questions related to the lecture material and polymorphism, then have a very nice afternoon. If I don't see you tomorrow on Friday, have a very nice weekend, and we'll return for lectures on Monday regarding interfaces.